Hi everyone, I'm Everton de Oliveira, Professor Água from the Instituto Água Sustentável. And this is our program Pompa, porque o mundo precisa de água. Or in English, because the world needs water. So that's why we have very smart people to talk to us about their experiences, and we learn with them. And today I have the pleasure to bring here my old friend Edson Wendland. Edson, he's a civil engineer from the University of Mato Grosso, and he was professor assistant at the Ruhr University in Alemania. I'm not sure if I pronounced that correctly because I don't speak German.
It's okay.
And is it correct?
Yes, it's okay. It's fine.
Oh, very good. Thank you. And he's a professor and was the director of the School of Engineering in São Carlos, São Paulo, at the University of São Paulo. Welcome, Edson. It's a pleasure having you here. We've been trying to lure you into talk to us here for a long time, and now we have you here. So let's go. Many people know Brazil has 12% of the world's fresh water. So please, could you explain the invisible part of this number, the main aquifers in Brazil, for our wider audience outside the groundwater community, please?
Okay. Hi, Everton. It's a great pleasure to talk to you, to meet you again, and it's always a great satisfaction to have the opportunity to talk about water resources in Brazil. Your first question is really interesting, is related about a number that everybody use and knows that Brazil has 12% of the fresh water availability in the world. And actually, very few people know where these numbers come from. And it has been defined or calculated during the 60s in the first evaluation, and it considered only the surface water discharge, only the water in the streams. So at that time, aquifers were very few studied in Brazil, and there was no information about the main aquifers. Nowadays, we know about these resources stored underground, and the main aquifers are located in the sedimentary basins in Brazil, which are very large. And I will mention just two of them. One is the Guarani aquifer that has been studied in the early of the 2000s, and it extends over four countries: Brazil, Paraguay, Argentina, and Uruguay, with an area of 1.2 million square kilometers. And it has a stored volume of around 40,000 cubic kilometers of water. It's a huge number.
It is.
And just to give you a comparison, the Great Lakes in North America store a volume of around 23,000 cubic kilometers of water. So Guarani Aquifer alone is supposed to store twice as much water as the Great Lakes in North America. A second very big aquifer in Brazil is composing the north region, more or less in the Amazon forest, and is composed by two aquifers, the Solimões aquifer and Alter do Chão aquifer, and both together has a volume of water approximately 8 times the water stored in the Great Lakes. So these are both the main aquifers in Brazil, and actually they haven't been considered at that time, as they calculated that Brazil retains about 12% of the fresh water in the world. So we have to review these numbers.
Amazing. Amazing. Well, with this number, and I've seen you talking about that before, this is going to dwarf any other country compared to Brazil. Brazil is already the first one, and it's going to dwarf even more the other ones, right? So it's
Yeah.
quite important the amount of water that we have here. And a question for you: is it possible for us to use all this water, or how likely is the possibility of doing that? One thing is having the
Well,
water, the other one is making it useful or available.
we have some technical difficulties because the water is stored in the subsurface and underground in the aquifer, which are normally sandstone formations that accumulate the water to a depth of around, let's say, over 1,000 meters depth. So it's quite difficult to pump all this water from underground. So we cannot use all this water out of is a very large volume available. We just have technologies just to a certain depth, and we wouldn't be able to use all this water with the technology of nowadays. Perhaps in the future, if we have crisis, more stronger water crisis, we will develop technologies to pump all this water. But nowadays, it's not possible.
Interesting, interesting. So, there's a report from UN, the Global Water Bankruptcy Report. It suggests that we have moved past simple scarcity into a state of water insolvency, where we are drinking the water of the future. That is a very, very serious, affirmation. Considering the research on the 15% loss of Brazil's surface presented by MAP Bioma, the surface water in the last decade, how can natural aquifer recharge help us restore what you might call our invisible economic infrastructure?
First, this number from MAP Biomas, they were calculated during the pandemic in 2020, 2021, more or less.
Yep.
And at that period, we had a very strong drought in the Pantanal region biome in Brazil, which is a wetland. And at that time, it was a very strong drought there, and the surface water in the Pantanal reduced a lot. Uh,
Okay.
After that, the rain conditions recovered again, and I was looking at Mapioma's more actual
Recently.
data, and nowadays we are 1.5% below the average. So it was a problem, a located problem at that time. And
That's very
after
good.
the rainfall recovery, the numbers are better again. And we have to differentiate by biomes. In the Pantanal region, we still have lower water areas, but in some other biomes like Cerrado and Caatinga, which is in northeast Brazil, the water areas are larger than the historical average due to the construction of dams for water storage. So we have to look at different biomes and how it functions. Of course, natural aquifer recharge is an important measure to retain water, and is what actually occurs in most of the areas in Brazil where we have enough rainfall, and the rainfall is larger than the evapotranspiration, that the conditions are given for water to infiltrate and recharge the aquifers, which store water for longer periods. So natural recharge is really a possibility to accumulate more water during the wet periods in Brazil.
That's interesting. Well, we know well. Nowadays, we talk a lot about the atmospheric rivers, the flying rivers, and this is going to be a hot topic and probably lots of investments to bring in more water into the continents and in Brazil, particularly through the Amazon forest or the other coastal forests that we have here, right? Uh, so one of the things that I was thinking is if we bring water in, we have to keep it in, right, for
Yeah.
the dry periods. Some of the times when we have a longer drought, not only for the next season, but for the next years. So this would this natural aquifer recharge be a way of getting around that problem? So having more water into the land?
Certainly, I think so. Aquifer recharge is a way to store water which is not exposed to evaporation or evapotranspiration if the water level is deep enough. And we really need to think about, because the situation in Brazil nowadays is that we always depend on the atmospheric water, on the precipitation. And if we have a year, a drier year with less precipitation, we normally have social problems because we don't have enough stored water for a longer period than 1 year. So we need to think about ways to store water for longer periods and perhaps survive during 2 years of drought or 3 years of drought with enough water reserves. So in this case, aquifer recharge is a very important strategy in this management strategy of water. And this brings us to the integrated water management, which is not really realized in Brazil because we have surface water and groundwater managed separately, and that's not the best strategy.
That's true. That's true. That's a fight for life for us, right?
Yeah,
Doing this for so
certainly.
long.
Yeah,
That's true.
certainly is.
So your 20-year monitoring project in the Guarani Aquifer outcrop showed a stark contrast in water partitioning. Grasslands allowed for 400 millimeters of annual recharge, while eucalyptus plantations, due to high evapotranspiration, allowed only 100 millimeters. Okay, based on these findings, how can we use slow water strategies, or mean like aquifer recharge, such as restoring specific types of vegetations to decrease surface runoff and force water to stay longer within the continents?
Yes, that's a study we have been doing experimentally, and these numbers are related to a short period of study.
Okay.
And during perhaps more rainy season, yes, at the end, we have been studying over 20 years the effects of land use and land change on the water cycle. And what we see is that the evapotranspiration depends on the size of the culture. So in this sense, grassland is a small culture and has reduced evapotranspiration, and eucalyptus is a large plant and has a larger evapotranspiration. So at the end, what we can decide is in which compartment we want to store the water. If we want to have groundwater recharge, we use smaller plants with less evapotranspiration. On the other hand, if we don't have enough evapotranspiration, we will have some concern with the air quality because the relative humidity in the atmosphere is reduced. At the end, we need the larger plants too to pump the water back to the atmosphere and have a larger relative humidity. In a comparison between forests, the eucalyptus is a large plant, and at the end, it has almost the same evapotranspiration as a wooded cerrado, a forest, because the plants are also pumping water and contributing to the relative humidity in the atmosphere. So we have to balance this storage of water in the ground, but we also need water in the atmosphere due to the climatic conditions. So it's a balance that we need to study really in more detail.
Yeah, I have this doubt, and I hope you could help me. We have many projects in the world where we trying to have, or people are creating agroforestry development, right? So you have plantations along with forests, and that actually adds water to the system. And that's a doubt that I have because we have more evapotranspirations, the roots are deeper and more transfer, of water to the atmosphere. And still, we tend to have more water inland due to the presence of forests. How that happen?
Well, that's also a good question, and we try to understand this at the field during our experimental works and monitoring. And the point is that larger plants have a larger leaves area
Hmm.
and contribute more for interception of the rainfall water. So if you have more interception, you are slowing down the water before it reaches the ground in all in the same time and contributes to surface runoff, which also contributes at the end to erosion. So the forest with larger leaf area intercept the water, slow it down, and contribute to recharge at the end because it is reducing the runoff and reducing erosion. At the end, it will use this water again in evapotranspiration, but the final balance is always positive. And we try to monitor this and show these numbers, how it really affects on the velocity of the water. At the end, so the forest slow down the water mainly through interception of the rainfall. And that contributes also to groundwater recharge.
That's interesting. That's interesting. What about have you guys studied the presence? Because as you have all the canopies and the leaves that intercept the rain and slow the water and actually reduce the erosion because
Yeah.
the rain drops are not hitting as strongly the soil. But also we have the I don't know how to say that in English, but the serapilheira, the leaves in the ground that develops like organic matter and also reduce the impact. Have you seen that in the field? Have you studied that, or that wasn't part of your study?
Yes, we have done such a work in a wooded Cerrado area,
Hmm.
and we're trying to see how the Serrapilheira contributes to the water retention. And
Hmm.
it has really a relative humidity and retains the water and also reduce the impact in the soil. And the impact normally contributes to the compaction of the soil, reducing the infiltration capacity. So if you have serrapilheira or other kind of leaves in the soil, it protects the soil from the impact of the water drops,
Hmm.
preserving larger infiltration capacity. At the end, it contributes to the infiltration of the water. First, the serrapilheira protects, retains the water, and then it flows slowly to the ground and infiltrates in the soil. And that's a second way of protection.
That's
And also protects from evaporation. Once the water infiltrates in the soil, you don't have a direct incidence of sun hitting the soil and contribution to evaporation. So the serrapilheira also contributes in this sense.
Oh, that's interesting. So when we think about the natural aquifer recharge that happens naturally, what about the monitored aquifer recharge? For us, it's a very common name. We call it MAR, right? Monitor aquifer recharge. But people that are not familiar with groundwater may not know that. So MAR involves intentional human intervention to store water underground. Well, given that Brazil faced severe blockades in its atmospheric flying rivers, do you see a technical and economical path for implement large-scale monitor aquifer recharge in unconfined systems, like the Bauru aquifer, that is a very important aquifer, or the Urucuia for agriculture, to create a strategic water reserve for drought periods?
Well, I think so. It's really possible. We have many sedimentary basins in Brazil. You already mentioned the Bauru aquifer, Urucuia aquifer. Are some areas in central Brazil, like in Mato Grosso, Goiás, which are all also sandy areas,
Yep.
which are very favorable for infiltration, with large porosity and infiltration capacity. The question is, how can we retain the water in these areas and avoid the surface runoff? So we have to do small dams, perhaps, in agricultural areas, retaining the water at the surface, which will infiltrate slowly and contribute to the aquifer recharge. This is a very good possibility. There is also the possibility of manage aquifer recharge using deep wells, but there's is another possibility, but we have to study this concerning the water quality. Depending the area where we are, we will have too many sediments infiltrating this water directly in a well. With after a certain time, we will have some clogging of the pores and reduced infiltration capacity in the well. So we have to think about a pre-treatment of water
Yes.
before infiltrating in order not to damage the aquifer. But we have very large surface areas in Brazil which are favorable for infiltration, sandy soils, and we just have to think how to retain the water in the soils to allow the infiltration. So we need to reduce the direct runoff. It will also contribute to the streams, which will not have so large peaks of discharge due to a very fast contribution to the streams. Keeping the water more in where it falls is perhaps the best strategy.
Interesting, interesting. So there's one thing that I always consider, because we have laws and we have all the concerns about, the place where the river starts, the nascentes, I always say in Portuguese, and we have, but then usually it's like 30 meters or 50 meters that you have to save, and actually that doesn't relate to the groundwater that generates that stream at that point, because we need a much wider infiltration area to keep the stream alive, right? Like running all year round. So one of the ideas is it many areas where we have agriculture in Brazil, we have huge areas, right? They already use terraces, right? So terraces helps infiltrating. Is it possible, or do you think we can improve that technology, like having terraces in many other places, or in more, all of them, for example, to keep the water in place so it could infiltrate faster?
Well, I think so. Yeah, is perhaps a strategy, and as you said, we have many agricultural activities in Brazil, and at certain point, even the agribusiness in Brazil will see that the most important insume for production will be the water,
Yep.
because we have large areas, we have good soil, we have sun almost all the time, and the restriction will be at certain time the water availability, including if we try to do multi-cropping, doing cultures of soybeans and maize at the same period, the restriction will be the water availability. And even for the agriculture, it will be a good strategy to retain the water in the field. So we have to transform perhaps our fields, as you said, like terrace or other retention ponds to keep the water in the field and use it during the agricultural activities. So you need to recharge the aquifer to have this water stored without compromising the surface area. You just retain the water for a certain period to infiltrate in the soil. without flooding it for longer periods. So that's perhaps the best strategy. And we have to transform our agricultural areas in this sense.
Interesting, interesting. So back again to the great Amazon aquifer systems that you mentioned, Solimões and Alter do Chão together, right? It holds a staggering number of 8 times the Great Lakes. It's 160 cubic kilometers, if I'm not mistaken. Okay, so how does the forest health, like the forest health, act as a pump, to maintain this continental storage? Is that important?
Well, as you said, Saga is a very huge aquifer, and there are many sandy formations, geological formations there, Alter do Chão, Solimões, and so on. And to recover the number, it's around 7 times larger than the volume stored in the Great Lakes in North America. So it's a huge amount of water. Um, it's located in the Amazon basin in this region with the big Amazon forest. And the water flux in this area is provided first by the ocean, water evaporation in the ocean. Then we have the trade winds that we call alisios, transport this humidity from the east to the west, and it precipitates in the Amazon forest. At the same times, the big trees in the Amazon forest are evapotranspirating the water from the soil and contributing additionally to the humidity in the air. And the alisios wind continues transporting this humidity to the west, and there is a natural barrier there, which is the Andean mountain chain that in certain way is a blockade of this humidity movement, and then it directs to the South Brazil or even South America and contributes to what we call the convergent zone of South America. And it contributes to the precipitation Southeast Brazil and South Brazil and even to Argentina and Paraguay. So, and in these systems, the big trees in the Amazon region are contributing to circulate the water in the Amazon region, taking it from the ground, evapotranspirating, putting in the atmosphere with the higher relative humidity and the given temperature conditions, it precipitates again and keeps circulating in the Amazon region. So it's important to have these big trees pumping the water, putting in the atmosphere, and contributing to this continental circulation system.
Interesting, interesting. Well, you talked a lot about the evapotranspiration, and in one of your you wrote many articles about that as well. And in one of your talks, you mentioned the because from people that are not familiar with the area where you studied, you we have a lot of rain there, right? The rain is actually very fair, and we have in great amount. But we also have a lot of transpiration. Can you give some numbers and ideas for people to understand why we don't have as much infiltration when we have so much rain in the area?
Yeah, okay. Well, I will mention first in the Amazon region, we have precipitations around 3,000, 3,500 millimeters a year, and the evapotranspiration is very high there. The plants pump, I would say, around 2,000 millimeters a year evapotranspiration. So you have a global balance, a positive balance of water in the Amazon region.
Yeah.
Another numbers, for example, here where we are in the southeast, in the state of São Paulo, and in our city, São Carlos, we have an average precipitation of 1,500 millimeters a year. And the vegetation in general, agriculture or natural plants like cerrado or Atlantic forest, they evapotranspirate around 1,000 millimeters a year, depending on the size of the vegetation. If you go to Atlantic forest, you probably will come up to 1,200 millimeters a year, or in cerrado, wooded cerrado, around 1,100 millimeters a year. So that's what the vegetation naturally needs of water to survive. With a precipitation of 1,500 millimeters, we have just a positive balance of around 300 or 400 millimeters a year. And that's the water that could infiltrate and recharge the aquifer, but also contribute to the streams, to the flowing streams. So it's not that much. The plant really need a lot of water. Around two-thirds of the precipitation is used by the plants, by the vegetation.
That's quite a lot. So from this 300 or 400 millimeters, could we make improvements in holding the water in the field? Is this number related somehow with some floods? Not in the region there, right?
Oh,
But
I'm sorry, I couldn't follow. That was a interruption here in the
that's okay.
transmission.
That's okay. I'll go back.
Okay.
We have 400 millimeters, but then we still have some problems, not all in the region there, but we still have some floods here and there, right? Of water going like runoff taking place. Uh, is this related to if the plants use two-thirds? It doesn't seem impossible that we could hold the other third better in the field, right? So avoid some, problems that we have today. What do you think?
Now, I think actually the discharge in the streams depends totally on the aquifers.
Yeah.
It's a
Yes.
drainage of the stored water in the aquifer. So it's better to improve the aquifer, the groundwater recharge in the maintain the water in the aquifers because it releases slowly during the year the necessary water in the streams. So if we don't retain this water, this excedent of 400 or 500 millimeters a year, if we don't retain it in the ground, it flows as surface runoff
Yeah.
very fast to the stream, and the velocity in the stream is very high. The water will flow away. So it's important to keep the water in the field, in the soil, and allows for the natural system to contribute slowly to the discharge in the stream. So there is, it seems to be a small number, 400 millimeters, but it is very big, is a norm volume of water. We have such large areas that at the end, the volume is very high. This is enough for our normal activities in the industry
Oh, yeah.
or even in the households.
Yes. Well, if we think that that like I mentioned, we're going to bring here in Brazil the Rajendra, the Indian, the waterman in India. He worked like a reforestation of about the whole state, right in Rajasthan in India, with 300 millimeters of rain a year, right? So
Yeah.
400 of excess water for us is it's a huge number, right? It's a huge number. That's interesting. Interesting. So you have, in one of your talks, you have described the water crisis as an architectural problem, right? How do we bridge the gap so the farmers, investors, hydrologists finally speak a common grammar? And I would like to say that I'm trying to work with. That's one of the aims of my work is to find a common grammar where we can talk to different people, and not only farmers and people that are not not necessarily hydrologists, But we have many hydrologists that don't talk to each other very well, right? We know that because everybody is specialized in something, right? So we have the hydrogeology is some sort of hydrologist as well, right? We
Mm,
have the sanitary engineers. They're also some kind of hydrologist, and they don't talk the same language, right? So
yeah.
how could we improve that for to make it to see that the situation is common for everybody, and we have to think together and at least walk in the same direction.
Yeah. Well, that's a really a good question. It's actually a long-standing question because so far we couldn't bring all these people together and talk the same language. So certainly is not there is not a single solution, a easy solution. Otherwise, we already would have it. So
Yes,
I'm
that's
not
true.
sure I also have the right answer to that. But I would say in the first approach, we would need to recognize and accept the different interests and points of view from each other. So if we respect the opinion of other people and try to discuss it more technically, about what happens to the water. Certainly, the people at the field, the stakeholders that work with agriculture, they know about what I would say the the crop water requirement, the water that the plants need to grow and produce what they need. They certainly know about that, and that water is an important issue for them. Even investors know that water will be important in the future, and we already have seen some wars related to water availability and water control. So it's important also for them to know about. But I think the more important approach, perhaps, it's to understand why the people are so interested in the water from the agriculture, from the household user, and bring all the stakeholders together. It's certainly difficult. And even the government, the policymakers, have to join these discussions and try to bring everybody together. It's certainly not a easy talk because most of the hydrologists we would say, well, we have to save all the water and we don't use it for any other activities beside drinking water or so water supply for animals and for the people. But perhaps we have to understand the point of view from each other and respect it and bring it to a technical discussion and try to provide water for everybody, for the population, for drinking, and even for the agricultural activities. I would say here in Brazil, we say nowadays that our agribusiness is feeding 1 billion people in the world. Brazil is producing food and exporting, and it's important for the Brazilian economy too. And it's also important for the whole world
Economy.
to have enough food. So, and one important issue is exactly the water. And we have to keep feeding all the people. We cannot stop to feeding them. And to bring to come up to a balance that look for the interests of all these involved stakeholders and the state and the whole world, we need to respect the opinion of each other and see why they need water and try to attend everybody. I think that's the way we can do this. Otherwise, we will not reach to a good end in this discussion.
I agree. I agree with you. I agree with you. I see that we reaching a momentum for that fight or that cause that we bringing along all our lives, right? Because we have no industry, especially now we have the data centers that they need a lot of water, and we people are keeping an eye on them on how they use water because it's so important. The development of mankind is totally focused on that solution and IT, right? So when we have that, we see the big companies, big corporations. Now they're talking about systemic problems that they have, or a supply disruption. If someone, due to lack of water, cannot provide anymore the industry, the whole system can go down. So this is an important problem. Now, this has been talked by many people in industries are thinking on water on a larger scale. And one thing that I don't that I see is that the people from industry, very few have good information on hydrology still, right? And on the other hand, people from academy have very little contact with industry, and especially the jargon of corporations, right? They use a
Yeah.
different jargon from, so we would have to that's a way of finding a common grammar, right? So, but then I'm kind of optimistic now, because since we have um, uh, this new theory, like the biotic pump, for example, how it works in bringing water to the continent, we have tools to rethink and reorganize the way the water helps us, and how we can manage water worldwide. What do you think?
I think yes, there's a big distance between academy and the productive sector. It's not really easy to communicate and
Yeah.
to inform this people. I think we have to look to the future and see what's going to happen in the water distribution and availability all over the country, for example, in Brazil, and taking care also of the climate change that we are discussing, warming up of the earth and the temperature increase everywhere. And it will also influence the water distribution, because we will have a warmer planet with more energy, certainly more evaporation from the oceans and transport to the continent, and it will change also the water precipitation in our country and perhaps in the whole world. So we have to consider also this in the discussion of the future. And for the investors, it's also important to understand how it may change and how it will influence the future water availability in different areas. You also need to take this in consideration when you do an economic investment. And that's perhaps important to bring hydrologists and climatologists
Together.
as consultants for these investment strategies related to the water availability. That is perhaps necessary in the future.
I think more than that, I think it's necessary right now. We need
Yeah,
we need this right now,
yeah, yeah, preparing the future. Yeah,
before it's too late, right?
yeah, yeah,
So
certainly.
good, good. So as we started our talk here, we are currently drinking the water of the future, as the report says, which is true. Funny thing is that we hydrogeologists, we work with groundwater. We know that we're drinking water from the past, right? The fossil
Yeah.
water in many places. But then that water belongs to the future as well, because it's our safety in water for the future. So, in an era of water insolvency, is it still possible to return to a sustainable hydrological balance?
Well, this is again a difficult
It
question
is, it is very
because
difficult, I know.
we are facing a transforming world. And as I mentioned already, the question of the warming up of the oceans and changing the rainfall distribution. So the question is, what is the normal situation, the normal balance? And possibly it will be really difficult to return to a water balance of 40 years or 50 years ago due to this warming of the planet and the redistribution of moisture and humidity. So we possibly need to think about adaptation because the time of mitigation is already over. We could mitigate the warming up of up to 1.5 degrees centigrade. This is already superated. Have this warming already. And possibly we need to adapt to the new conditions because returning to the previous temperature will take a long period. We need around 200 years to since the Industrial Revolution to warm up the planet. Certainly, we need a long period to cool down the planet. So, in this meantime, we need adaptation due to the present conditions that are being much and more different from the past of 50 years or 100 years ago. So, come back to the water balance as we were used to do is really challenging because the new distribution of water. We have to cool down the planet first in order to come back to the normal water balance.
Well, I would say that I'm a little bit more optimistic than you are, then, Edson. I believe we can, if we work hard on managing forests and bringing more water into the continents, we may be able to do that in a shorter period of time. It's not easy, but it's not impossible. Like it happened in some places in China that they're reforesting the plateau there. I forgot how to say that in English, right? The last plateau, lost plateau. I don't know how they say that in English.
Yep.
Or in China, it happened. So or we have the Great Wall that's been built in Africa. So those are promising huge experiments for us to learn and to mimic in other places. And I always tell to my students. Now I'm not a professor at the university anymore, but I talk to many students, and I believe it's a promising time for becoming a hydrologist, don't you think? Right? Because
Yeah. No, but I think we are not talking having a different view because that's what I call adaptation.
yep.
We need to adapt our water use and strategies to retain the water in the soil because the distribution will be different of the atmospheric water. And this retention and different land use strategies is adaptation. You have to adapt to a new condition because it will take very long to return to previous precipitation distribution. So I think we are having the same view to the future, and we need to adapt and develop strategies to keep the water in the ground, in the soil, and that is more available for different uses. I think I'm not skeptic, but I think we need adaptation. We need to do some activities and strategies and plan and projects to adapt to the new condition.
Very good, very good. Thank you very much. Could you? I'm very glad to talk to you. I've been trying to get you here, but we were so busy in the past. Good to have you here. So please make your final considerations. That's all.
Well, it was a great pleasure to talk to you again. I thank you for the opportunity to share some ideas and discuss about this very interesting stuff related to water availability, water sustainability, and how can we adapt to the future. And it was really a great pleasure to share some ideas in this discussion. Thank you very much for the opportunity.
Thank you very much, guys. I have here with us Edson Wendland. He's a great guy. He's a great friend and a great academic. So please, if you haven't followed his papers, take a look. Very nice stuff for you to learn. And keep an eye on his work. And if you're looking for a nice place to study, look for his school. It's a great place. Thank you very much, Edson. I'll talk to you later. Thank you. Bye.
Thank you. Thank you very much.